Press the bell icon on the YouTube app and never miss any update from Tech Primers. Let's take a look at the facade design pattern. Facade design patterns are useful when we want to make our API easy to use. Easy to use in the sense, if there is an existing API, we can create a facade class which will abstract out the underlying implementation of an existing class. Generally, facade is used to hide the implementation and hide some unclear code or unclean code so that the client doesn't know what's happening underneath. It reduces the dependencies of the outside code, so the client will not be able to see any other dependencies of how to create a composition, because facade internally uses composition. Facade doesn't even require any interface. It is usually useful when we want to refactor any existing class. Since we use it as a part of refactoring, it hides the complex or in fact a bad code which is written. Let's try creating a facade design pattern. I'll create a new package called facade. Similar to how we use the phone examples in the previous patterns, we will be following the similar pattern here. I'll create a phone interface, and this interface is going to have a method called build. Let's try returning that. And I'll just create a facade demo which will have a public static void main for us to run. We need to create interfaces implementation. Let's imagine these are the bad codes. I'll create a iPhone and the build is going to return saying built using iOS, let's say 11. I'll create a OnePlus, built using Android, let's say 4.0. We can even add one more Nokia phone or even Microsoft's phone. So we have different implementations here. Now let's imagine the client is present here. So the Facade demo is the client, and this particular client needs to access a phone. We can create a phone facade. We can create one more class called facade phone, and as a part of the constructor we can create the different classes. We can create all the implementations here: iPhone, Nokia. So now we have created a composition of these objects. Now we need to expose these API specific to the client's implementation. We can expose a facade phone which says build iPhone, which will build an iPhone. The return type would be string. So I'll just call iPhone.build. So this is just going to call the iPhone specific method. Let's do a return here. Similar to that, we will be creating build Microsoft phone, or we can name it as build Apple phone. Internally, it's just going to call the iPhone. Here we will be calling the Nokia phone. The next and the final one would be build Android phone, and that is returning OnePlus build. Imagine that these implementations or these classes are not written in the right way. In this particular example, I just had an interface and I have directly implemented these interfaces, so which looks neater. Imagine that there are different interfaces and different pluggers which have different design patterns existing already, and they look clumsy. However, we want to expose these to a client so that he can directly use it. That is when we can enclose everything in the facade class. Imagine we have a facade class here and we have abstracted out some complex code or even the bad code which we have written in different implementation. Using the facade phone, we are going to build the Apple phone, Microsoft phone, or the Android phone. Let's try using it here. Let's create a new implementation of the facade demo, or in fact the facade phone, right? Let's try creating a variable. Now using the facade phone, since the facade demo is the client, we can directly call methods like these. You can directly say Android phone, Apple phone, and the Microsoft phone as well. So the client's code looks much neater and simple. We have not created any instance of each of these phones. However, Facade has created that for us as a part of the constructor, and we are directly calling these build methods whenever we require them. If I run this program, this will just print the build of each phone, nothing else. But imagine a complex scenario where you have lots of complex code under different packages and you want to expose that to a client, and that is when you will be using, I think this has a return type, so we need to use, I'll just say .s out. So imagine that in the real-time example, you have a complex use case where there are different packages and different implementations which are very complex and you don't want to touch them. However, you want to have a client. That client needs to use these implementation. We can abstract that out from the client by creating a facade, and the facade acts as a interface for the client. That is when we can go for facade. See that the values are just getting printed. So what are the disadvantages of using facade? Since facade is very simple to implement, we don't even need an interface. People tend to overuse it. And if there are too many facades in a project, that shows up the code smells, and there are lots of legacy or complex code which are lying underneath, which is not exposed. Generally, as I said earlier, it is used as a cleanup or design pattern where you can use facade when you want to abstract out and you don't want to change much in the complex logic. You just create a facade and then you abstract things from the client. Generally, it is used when you want to clean up code. I hope you guys understood what is facade design pattern and where we can use it. Meet you again in the next design pattern video. Thank you very much.